Hello everyone, my name is Parth Balian, and I'm going to be presenting my Math and People project. So, the person that I chose for this project was my dad. He's a businessman, and the kind of math that he uses is just basic math. And the way math relates to him is just that, he uses math all the time in his business. And so, yeah, the math problem right here, as y'all can see, Tom was riding his bicycle to the park, and he always rides it daily to the park for about an hour. And the purpose really is to just figure out how many hours a week he rides his bicycle to the park. So there's 7 days in a week, and yeah, you would just multiply that by that hour that he always rides his bicycle to the park like daily, and yeah, you would get 7. And yeah, he always rides his bicycle to the park like 7 hours a week. And the math, it's right here. So yeah, and my final thoughts are that I think this project was very interesting. I liked it a lot. And this kind of math problem is the exact kind of math problem that my dad has solved before in his business. And these kinds of math problems are computed weekly for this very word problem that I was explaining like earlier in the video. And yeah, that's it. Thank you everyone for watching this video. Goodbye.
Hello, my name is Kimberly Garcia. I'm in Math 171. My professor's name is Ms. Cropper, and this is my Math and People project. The person I'm going to talk about is Omero. He's a site manager, and the math he mainly does is calculus, like finding the area or the volume. A scenario of his work would be, this would be the diagram. It's gonna be 6 feet of depth. These little ledges are 2 feet. And little side note is that each foot of dirt is 3. Where would this go? It would be right here. I don't know if you can see it, but this would be how it would be. And the slope would be 45 degrees. It's required to have a slope of 45 degrees. What you're trying to find is the cubic feet of dirt. How would you find this? You would use you're technically trying to find the volume in general. You're trying to find the volume in general. So you would use length times width times height. In this case, it's technically depth. So to find the full length, because it's not just the full, it's not given the full length, you're gonna have to do 6 times 2. 6 times 2 is 12. So that's your full length. 12 right there. The width would be 3. The side note right here, bottom. And then you would use the height, which is the depth, which would be 6. When you multiply all this, this will come out to be 116 feet. this is what you find, and so the final answer would be 160 cubic feet of dirt. And this is a scenario of what the work he does every week.
Hello, my name is Ishmael Little, and I'm here with Egypt Minor. She's my girlfriend and a registered sleep tech. She does math every day on her job. Being a sleep tech, they use all areas of math to calculate how long people sleep, how efficient someone sleep, and how long they're in a particular stage of sleep. Sleep latency equals time from lights out to the first epoch of sleep. The purpose of this problem is to measure how quickly someone's brain transitions from wakefulness to sleep. This is calculated with each person. For example, lights out equals 10:30. First epoch of sleep equals 10:47 p.m. And that gives you 10:47 minus 10:30 equals 17 minutes equals sleep latency. And that's how math goes into her everyday work.
Hello, my name is Caleb Dickens, and this is my Math and People project. So for this project, I interviewed my sister. Her name is Amber, and she is a staff accountant for an accounting and tax firm. I chose her for this project because she uses math in her everyday life to calculate things like payroll tax withholdings, sales tax, and net income. In this presentation, I'm going to be explaining the processes and equations she uses specifically to calculate federal payroll tax withholdings. Now, before I dive in, I just want to give a little introduction to what accounting actually is, and it's basically just the process of recording, organizing, and reporting a company's financial transactions. Amber's position as a staff accountant encompasses a little bit of everything in this field, from payroll and sales tax compliance to recording daily financial data and producing reports that make it all come together. Federal payroll tax withholdings. So for federal payroll tax withholdings, we're going to be using a combination of equations to calculate withholdings for federal income tax, Social Security tax, and Medicare tax. The sum of these three taxes is what's calculated to find the total federal payroll tax withholdings. So for this demonstration, I'm going to be using a quarterly income of $10,000 to calculate that withholding. Form 941. So this is the IRS form that's used to report and pay an employer's federal payroll taxes quarterly. So we see a lot of values going on in this form. I went ahead and plugged in the $10,000 amount to this form. And in the following slides, I'm going to be explaining the equations behind those values, beginning with box 3 for federal income tax. So federal income tax is calculated using a standardized rate of 12%. And with taxable wages at $10,000, we get federal income taxes of $1,200. Next up, we have the Social Security tax. This is seen in box 5A of Form 941, where they multiply 10,000 by 0.124. So I've just broken it down into two separate equations, which are the same because there's an employee portion and an employer portion, both being 6.2%. So once you calculate that and add them together, you get $1,240 for Social Security tax. Last but not least, we have the Medicare tax equation. So this is the same situation as the Social Security, where in the form you can see in box 5C, it's multiplying 10,000 by 0.029 to get the 290 amount. So I just broke it down again for the employer and employee portions.
Hello, my name's Haley Wiggins, and today I will be doing my Math and People project. The person I chose was Denise Floyd, my mom. She is a home health care nurse that uses math every day to ensure her patients are as happy and healthy as they possibly can be during their final stages of life. Denise uses medication dosage math in her career, and she is the go-to person for this, and no one has to check over her math. She went to nursing school beforehand to properly understand it and apply it to her career. The example she gave me was patient X has an order for comedian, 7.5 milligrams on Monday, Wednesday, and Friday, and 2.5 milligrams on all the other nights. The pharmacy sends 5 milligram tablets. How do I teach a patient to properly take the medication? The purpose of this problem is to educate a patient on how to properly take something that has been prescribed to them, and she uses this math daily. The formula for this is dose ordered over dose available in milligrams. But I will also be showing you how to convert grams to milligrams and milligrams to grams. The step 1 on the medication dosage is to write down what the prescription calls for and how much is prescribed. So she is doing the comodium. It's Monday, Wednesday, and Friday that she needs 7.5 milligrams, and any other day is 2.5 milligrams. And the pharmacy sends 5 milligram tablets. You plug those numbers into the formula given. 7.5 milligrams needed over 5 milligrams in one tablet. 7.5 divided by 5 is 1 1/2. And that's how many tablets the patient needs to take each Monday, Wednesday, and Friday. Any other day is 2.5 milligrams needed over 5 milligrams in one tablet. So 2.5 divided by 5 would be 1/2. And they can use the tablets that they had left over from here on these days. Now, a side note. Sometimes nurses and pharmacists have to convert grams to milligrams, and this is how they do it. To convert a milligram to a gram, you have to multiply it by 1,000. And to convert a gram to a milligram, you have to divide it by 1,000. So an example would be you need to convert 0.25 grams to milligrams. So you plug it into the equation. 2.5 grams times 1,000 equals 250 milligrams, because you have to move the decimal point over 3 points to get the 250. So it's really simple. So our final thoughts were that Denise thinks that math is essential to her career, and she was not surprised to find it throughout it, because it was taught during her time as a nursing student at RCC. She would not have wanted anything different, and her biggest advice to people is to make sure you love your career, because you'll never work a day in your life if you do. I enjoy learning about this because it will be a part of my future career, and I had to do a little bit of research to find what the medication dosage math was.
The subject for my presentation is my father, Jason Wise. He is an engineer for the CSX Railroad. That's a train right there. Math is important in his job because he needs to know how long it will take a train to get from location to location. Engineers must use minutes per mile to keep track of time. To find this, they divide total time in minutes by distance. Here's an example of a problem my father might do. Jason has been working for 8 hours. He is only able to work 12 hours at a time. He wants to get this train to Florence, and he's currently in Selma, which is 130 miles away. It took him 1 hour to get to Selma from Rocky Mount, which is 40 miles away. Can he get to Florence before his 12 hours are up? So first, we need to know how much time he has. So we take the total time, 12 hours, minus the time he's already worked, 8. And we find 4. That means he only has 4 hours to get to Florence. This is the route he's taken. So he's already gone from Rocky Mount to Selma. That's 40 miles. And he wants to get from Selma to Florence, which is 130 miles. It took him 1 hour to get from Rocky Mount to Selma. So the first thing we need to do to figure out how long it'll take him to get from Selma to Florence is find his pace, which is minutes per mile. So it took him 1 hour, 60 minutes to get to Selma, which is 40 miles away. 60 divided by 40 is 1.5. So for every 1.5 minutes he travels, he goes 1 mile. We take the distance from Selma to Florence, 130. We take the distance from Selma to Florence, 130, times the time it takes him to travel a mile, 1.5, and this equals 195. But this is still in minutes, and we want it in hours. So we divide by 60 to get hours, and that gives us 3.25. Since 3.25 hours is less than 4 hours, he has enough time to get to Florence.
On my cell phone, late night when you call me on my cell phone, late night when you
Hi everyone, so my name is McCaden Hunt, and for my Math and People project for Math 171, the person that I chose was my mom, and her name is Crystal, and she is a cosmetologist, and she's been doing hair for around 15 years now, and I chose her for my project because I see her go to work every day, and I just wanted to understand how she used math in her everyday job. So for her job, she used basic math. So for the problem that I chose was, so say if my mom charges $50 for a cut, so she does 3 cuts, and she charges $50 for the cut. 4 cuts, and say she charges $35 for a style, so we'll say she does 4 styles in one day, so she charges $35 for style. And we'll say she does a color, and we'll say she does 2 colors in a day. So we're trying to figure out how much money she makes in one day. So $80 for a color. Sorry. And we'll say a $10 discount for one of our customers. Okay. So how much does she make in a day? Okay, so we have $50 for a cut, $35 for a style, $80 for a color, and she does 3 cuts a day, 4 styles, and 2 colors. It would say that she does a $10 discount. So step by step, we'll say 3 times 50 equals 150. 4 times 35, 140, and for the color, 2 times 80 equals 160. So a little simple math here. 3 times 50, 150. 4 times 35, 140. And 2 times 80, 160. So we're going to add all those together, obviously. And we'll get 450. And we can't forget the discount. So 450 minus $10 discount, 10. So in one day, she made around 140 or 440. Sorry. That's my answer. So that was my math and people project. Simple math that she uses step by step right here. Again, 3 times 50 for a cut, 4 times 35 for a style, 2 times 80 for a color, and the 10 discount. And that was how much she made in one day for all of these simple math. And that's why I chose my mom's career. And yeah, that's all I got. And thank you for your time. Goodbye.
I'm John Kester II, and the person I'm covering for my Math and People project is my father, John Kester, who is the Dean of Engineering here at RCC. The math problem that he uses in his work is total contact hours divided by 512 equals full-time equivalency. Total contact hours is equal to the number of students in a class times the credit hours of that class times how many weeks that class is. FTE is how the state figures out how much money to give to the college. The example I will be using is this class, Math 171, in the spring of 2026. This class has 28 students, 4 credit hours, and is 16 weeks long. Using this equation, or the extended equation to make it easier to plug in, we get 28 times 4 times 16 divided by 512. When you multiply this out, you get 1,792 divided by 512. This means that this class's total contact hours is 1,792. When you divide this, you get 3.5, which means that this class's full-time equivalency is 3.5. Now, this number may not sound that impressive by itself, but it does matter when it gets added to the FTE from all the other classes across the college. This class gives 3.5 FTE, but when you repeat that across many classes, the total becomes much, much bigger.
Hey y'all, my name is Jeremiah Bulger, and this is my math and people project. So for my project, I chose to do it on my sister. She's a paramedic and uses math like this on the daily. And this is just like drug math and like having to do conversions and stuff like that. So for this scenario, you have a 4-year-old male who has a temperature of 103. He weighs 36 pounds, and the Tylenol dosage is 15 milligrams per kilogram for a temperature greater than or equal to 100.4 Fahrenheit. And so our Tylenol, we have 120 milliliters of Tylenol, and it's packaged 60 milligrams per 5 milliliters. That will come in handy later. So first we're going to start with 36 pounds divided by 2.2 because there are 2.2 kilograms per pound. And once you divide that out, you're going to get 16.36. And now you've got your 16.36. You're going to take it and multiply it by your 15 because that is the dosage amount. So 16.36 times 15 is going to give you 245.4. So now you've got your 245. You're going to have to divide that by your 60 milligrams because that's how it's packaged. So 245.4 divided by 160 is going to give you 1.53. And since it's packaged 160 milligrams per 5 milliliters, you're going to divide what we just you're going to multiply what you just divided. You're going to take your 1.53 and multiply it by your 5 milliliters. And so that's going to give you 7.63. And since we're dealing with like medicine and stuff, we're gonna have to round it to our nearest whole number. And so that's gonna give you 8 milliliters of Tylenol. So to answer the question, how many milliliters of Tylenol will be needed, it's gonna be 8 milliliters for this patient.
Hey y'all, so this is my mom. Her name is Misty Smith. I chose her because she is a pediatric educational diagnostician and she works with children 3 and under. She's also a supervisor at the CDSA. So I'm going to go ahead and ask her what her career is and kind of what it's all about.
Okay, so as Jude said, I'm an educational diagnostician at the Sand Hills Children's Developmental Services Agency, and we do the North Carolina Infant Toddler Program. My role here is to go out when we get a referral for a child and do standardized developmental testing to determine if they might be eligible for our program based on their scores.
Evaluates kids and has to add up their score to see if they're eligible for the program. What type of math do you use in your career?
Math every day, always, but just basic math and statistics as well related to standardized testing.
You are the go-to person, aren't you?
Yes, I'm the go-to.
Yeah. Was this math something that you learned on the job or did you kind of know before?
Both. I learned the basics and a lot of it in college because I took statistics in college and I took evaluation and testing classes. So I knew about standardized testing. I knew that math was involved. I knew some of the math, and then I learned some of it on the job.
What is the purpose of the problems, and do you do these problems daily or weekly?
I do the problems daily. Several things I do, but I think what you're demonstrating for them is how I determine a child's chronological age. So the reason we do that, that's the first thing we do when we start a test. We need to know exactly how old the child is so that we can compare them to their same age peers. That tells us if they're behind developmentally in any area. If they are, depending on how far behind they are, they may qualify for our program.
Here's like the form that they fill out when they go to see a child. This is the cognitive one.
So that's how we get our, what we call our raw scores, and they get transposed here, and then we use charts. After we get this chronological age, that tells us which chart to look at with and take that raw score and give us our standard score. So that's some of the statistics there.
What are your chosen person's thoughts regarding math in their career? Were they surprised to find math on the job, or was it the type of problem solving they were expecting?
I was not surprised. I knew going into it that I would be testing, and because I had taken college courses in evaluating and in statistics, I knew kind of what to expect.
Looking back, would you have done anything different to better prepare for the math in your career, or do you have any advice you want to give to people interested in your field?
I felt prepared. I enjoyed those classes in college, and I think when you enjoy something, you, even if it's something difficult, then you pay attention and you kind of have that motivation to pay attention and learn. As far as advice though, I would give others, ask questions before you get too far behind. If you don't understand something, speak up, check in, make sure you're on the right page before moving on to something bigger.
What are the takeaways for me from the interview with my chosen person? Is the type of math that I was already familiar with, or did you need to do a little research to understand it? Were there any results that surprised me about my future career and goals? What type of math problems do you already know to expect? The type of math that she was doing was basic subtracting, sort of, with a little bit of pizzazz added to it. You have to learn from her exactly how they do it, her program. After she taught me, it was pretty easy to catch on to. My career goals in the future is kind of cool because I want to be an occupational therapist for pediatrics. So if I don't work with my mom directly, I would work with somebody who is doing the same exact thing as my mom. So it'll be useful for me in the career. It's fascinating how she concludes her results. Hey y'all, today I will be explaining and showing you how to figure a chronological age as an educational diagnostician, which is my mother's occupation. So I'm going to show y'all how she does it every single day using a hypothetical kid. For year, month, and day.
First, we're going to write the day that we are evaluating this child. 26, but you don't want to write the 2000, you just want to write 26. It's the third month. It is the 15th. Current date. Here we're going to write the child's hypothetical, in our case, date of birth. Say it is 24th, so 2024, November, so the 11th, and then November 30th. So this is the day of the month, this is the month of the year, and this is the year. Date of birth, so I'm going to say DOB. Now we're going to have to do the actual math. You cannot subtract 30 from 15 and get a real age, if that makes sense. So we're going to have to borrow from the month. We're going to cross out our 3, we're going to make it a 2. We're going to take a month's worth of days and add it to 15. So how many days are in a month? She always goes with 30 in her job instead of 31. We're going to add 30 to 15 equals 45. I'm going to subtract 30 from 45. This would be 15. Month column now. We can't subtract 11 from 2. We can't count over the year. We're going to take 1 away from year and we're going to make it 25. We're going to get a year's worth of month, which would be 12 months in a year. We're going to add 12 to our 2 equals 14. 14 minus 11 is 3. And here in the year column, we have to do is subtract 24 from 25, which would be 1. Our hypothetical child, 1 year, 3 months and 15 days. That is how you figure chronological age. Child is 1 year, 3 months and 15 days old.
Hey, my name is Odyssey Rush, and today I will be discussing a project we are doing for math class named Math and People Project, where we explain a specific person we picked because their job involves math. The person I chose name is Michelle Butler. Ms. Butler is my school's front desk person. Her career is a bookkeeper. I chose her for my Math and People project because she deals with students' fees and club funding. Ms. Butler uses arithmetic math in her career, and when Ms. Butler uses this math, people still check over her because she counts by hand or on a calculator. Ms. Butler learned this math beforehand. One problem Ms. Butler might solve is a problem like 2,095 plus 75, or something smaller like fees, 85 plus 40. She uses these types of problems to ensure the money for certain clubs is in their account. She even uses this type of math for fees calculations for students with fees from their elementary school and up. She does these problems monthly. Example, one problem Ms. Butler might solve is the Beta Club account, which might have had $8,135 in it, which was added with $400, $30, then $75. All of that equaled up was $8,640 that's in their account. Another one could have been fees from elementary school to high school, which could have been $75 plus 25 plus 36, which would have been $136. Another one could have been computer fees paid off and went off of their fees, which was 85 minus 25, and that would have been $60 left all on their fees. To explain the Beta account a little more, Beta Club can have $8,135 in their bank account from the previous year, and during this year, students brought in some money from a fundraiser. They brought in $400, $30, and $75 could have been from another student. She would then calculate the money all together and get $8,640. She would get more money throughout the day, so later she would run to the bank in order to get the real balance on the account. Butler's thoughts regarding her job in bookkeeping involving math was that she was expecting it. She knew her job involved math, so it wasn't a big problem. Looking back, she wouldn't do anything differently to better prepare for the job. The advice she wants to give people is to not work here. It doesn't pay enough. The takeaways I got from my chosen person was that a bookkeeper for a school is very important to keep. This was also math I already knew, and I think I used harder math instead of a simple equation. The only result that surprised me was how much money Beta Club could even get. My future career and goals don't involve math, at least I don't think it do. And I would really be surprised because it's just involving keeping clients out of jail and justice for them.
Hi, my name is Emma Stevenson, and this is my Math and People project for Math 171. So for my Math and People project, I chose my mom, Denise Gallops, who is a family nurse practitioner and works at Pinehurst Medical Clinic. She uses 2 forms of math in her career, which are dimensional analysis and algebra. Dimensional analysis is a technique used to convert units of measurement and analyze relationships using units of measurement. Algebra is a technique that uses variables to represent certain values. She uses these two forms of math to ensure patients receive proper treatment, and she may use these forms of math when calculating a patient's weight in kilograms and giving out prescription medications to said patients. So with that being said, let's look at an example. Okay, so here's our example. Timmy is a 5-year-old boy who weighs 44 pounds and exhibits the symptoms of a sore throat, coughing, and runny nose. He is tested and his results come back that he has the flu. For the flu, Tamiflu is the medication prescribed and its dosage is 3 milligrams per kilogram per dose. So the first thing we need to do is find Timmy's weight in kilograms because that's what we need for this equation. So here we have the formula for finding weight in kilograms. We have pounds over 2.2 equals weight in kilograms. 2.2 pounds is equal to 1 kilogram, which is why we're using 2.2. So we're going to plug our values in, which is 44 pounds. So we plug 44 in, and that gives us 44 divided by 2.2 equals x. So we get 20 equals x. So Timmy's weight is 20 kilograms. So now that we have Timmy's weight, we now need to plug it in to this equation here. Now, for a general equation of dosages for medicines, it's milligrams equals dose over kilograms. But since we're using this equation, it's going to look a little different. So it's going to be 3 milligrams equals x, because we don't know the dose, over 20 kilograms. So we multiply both sides by 20 kilograms, which is going to give us 60 milligrams equals x. Now the Tamiflu dosage is 60 milligrams. This means that Timmy will receive a dosage of 60 milligrams of Tamiflu, hopefully so that he can recover from having the flu. I'm Emma Stevenson, and this was my Math and People project. I hope you enjoyed.
Hi, my name is Javion Smith, and for my Math and People project, I interviewed my mom, who was a realtor. A realtor is someone who helps people buy and sell houses. I chose my mom because I wanted to learn more about what she does and how math connects to her job. At first, I did not think real estate used that much math, but after talking to her, I learned that math is actually a big part of her work. One of the main ways my mom uses math is by calculating commission. Commission is the money a realtor earns from helping selling a house. This is usually based on a percentage of the sale price. For my example, I'm going to use a house that is sold for $300,000 with a 6% commission. The first step is to change the 6% into a decimal, so 6% becomes 0.06. Next, I multiply 300,000 times 0.06. That gives me 18,000. So the total commission from selling the house will be 18,000. Sometimes that commission is split between two agents, like the buyer's agent and the seller's agent. So to find how much each agent gets, I divide 18,000 by 2. 18,000 divided by 2 equals 9,000, so each agent will earn 9,000. The math is important because it helps realtors understand how much money is being made from the sales and helps them explain costs clearly to their clients. My mom told me that she uses math like this a lot, especially with working with prices, percentages, and estimated payouts. She also said that math is not always hard, but it is very important to be accurate. A small mistake with numbers in real estate could cause problems, especially when people are making big financial decisions. Something I learned from this project is that math is used in jobs more than people think. Even in a career like real estate, where you may not picture solving math problems all day, numbers are still a big part of the job. This project helped me see that math is useful in real life, not just in classrooms. It has also made me realize that understanding percentages, multiplication, and division can help in many careers.